everyone, welcome to video 2 of prime factorization. Before we really talk about what prime factorization is used for, let's kind of talk about how we can write it. So we need to remember that exponents is a small number or small raised number to tell how many times to multiply a factor by itself. So an example, 5 to the third power is 5 times 5 times 5. So the reason why we're talking about exponents with prime factorization is because sometimes when we write prime factorization, we have numbers repeated over and over and over again. Now, mathematicians can be lazy sometimes, and they don't want to write these numbers over and over and over again. So instead, they have a shortened form, and that's where exponents come in. So in this example, we have the prime factorization of the number 5,000 is an expanded form, 2 times 2 times 2 times 5 times 5 times 5 times 5. Whew, that would be a lot to write down, but we can shorten it by grouping our 2's together and our 5's together. So I see that 2 is being multiplied by itself 3 times. So we can write this as our base, which is 2, because that's the number that's being multiplied by itself. And we're going to raise that to the third power. So 2 to the third power is the exponential form of 2 times 2 times 2. Now we can do the same thing with the 5. So 5 times 5 times 5 times 5. That's 4 times 5 is being multiplied by itself to get 5 to the fourth power. And we've shortened it. The exponential form for the prime factorization of 5,000 is 2 to the third power times 5 to the fourth power. So it's not only important to be able to write it, but it's also important to read it as well. So powers have different names for them. If you have this 2 right here, that can be read as 3 to the second power or 3 squared. So again, that's only if that little 2 is by our base. It could be second power or squared. Now, if you have a third or a 3 in the power spot, this can be read as 5 to the third power or 5 cubed. So there are 3, it could be to the third power or cubed. And then if you have any other number besides 2 or 3, then we're going to read it in a form similar to this. So in this example, we can read it as 2 to the fourth power or 2 to the power of 4. So that's the same thing with any other number that might be there. We'll say whatever the number is to like the fifth power or to the power of 5, and they can say the same thing with 6, 7, and so on and so on. So this is how we read all of the powers. Now, what do we do with these prime factorizations? Well, we can find the greatest common factor with it. So our question for our example in here is find the greatest common factor of 24 and 60. Now in the past, what we've done is we have wrote all the factors for 24 and 60 and then combined them together. That's just one method. We can use this method instead. So step 1, find the prime factorization of each number. And I've already done this for you just in this example so that I can show you the new parts, but we've talked about how to find the prime factorization of each number. So if you need a review, make sure to look at the other video. So after completing those steps, I found the prime factorization of 24 was 2 times 2 times 2 times 3. And the prime factorization of 60 was 2 times 2 times 3 times 5. Now is when we're moving on to something that's brand new. Step 2, find the longest factor string that they both have in common. Okay, well, I see that for 24, it was 2 times 2 times 2 times 3. Then for 60, it was 2 times 2 times 3 times 5. Well, hey, look at that. Both of them have the numbers 2 times 2 times 3 in both sets. That's going to be the longest factor string that they have in common, because the only other numbers, or the only other number or prime factorization for 24 is 2, and the only other number is 60. Everything else matches. We're looking for all the numbers that match between these two. Great. Now we can move on to step 3. Multiply the factor string to get the greatest common factor. So I'm going to take my 2 times 2 times 3 and multiply those together. 2 times 2 is 4, times another 3 is 12. And hey, look at that. We have found the greatest common factor of 24 and 60, which is 12. Okay, so we found the greatest common factor. Let's try finding the greatest common multiple. Okay, here we go. Now we're finding the greatest common multiple of 24 and 60. So again, step 1, find the prime factorization of each number. Great, that's already been done. Again, if you need a review, please look back at the other video. Now I can move on to step 2. Find the longest factor string that both have in common and write it once. Okay, well, I'm going to rewrite my numbers again. I got 2 times 2 times 2 times 3, and 2 times 2 times 3 times 5. Okay, it looks like the same steps as last time, or when we're finding the greatest common factor. So I rewrote it, and then it says, and write it once. Okay, so I have my numbers that are in common, the 2 times 2 times 3, and I'm going to rewrite it once, just like my directions say. Okay, looking pretty good. Then attach the numbers that are not part of the factor string. We should add are not in there. Okay, so taking a look at it, I see that 2 and 5 are not included in this section right here. So I'm going to add my times 2 and my times 5 at the end. So this was a little bit different than finding the greatest common factor, because with the greatest common factor, we just took what was repeated and we stopped at that and we multiplied them together. Now we're taking that chunk, but we're going to also multiply it by those two numbers that were left out. Okay, step 3. Multiply to get the least common multiple. Okay, let's multiply all these together. 2 times 2 times 3 times 2 times 5. Okay. So we got 2 times 2, which is 4. 4 times 3, which is 12. Then over here, 2 times 5. 12 times 10, which is, of course, 2 times 5. You can multiply all those together to get 220, which is the least common multiple. Now, I understand that this can be hard when you just first look at it. Please make sure that you're using your notes when you're answering these questions, and that if you have any questions that can't be answered in your notes, you talk to me. So I hope that this helps, and see you in our next video.